off, finishing off lesson 6, the trigonometric ratios, the trig functions, the sine, cosine, tangent. We already talked about the fact that the sine of the angle is equal to the ratio of the opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse, and tangent is adjacent over, or opposite over adjacent. So what happens if you know the side lengths but you're trying to find the angles? Okay, that is when an inverse trigonomic function comes into play. You take the inverse function of that ratio. So the angle equals the inverse of whatever the ratio is. So to use your calculator on this, right above your sine, cosine, and tangent, you will see it's usually the second function right above the exact one. So the inverse to sine is right above the sine, the inverse to cosine above cosine, and the inverse of tangent above tangent. And we are going to use that. So we will have to hit the second before we hit the sine and cosine. But we still use the same, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So turn your paper over, and this is what I'm referring to. What happens when now we know two of the side lengths, but I want to find the measure of angle y. So I want to find this angle right here. Now, looking at, so this angle y, I have the hypotenuse and I have the adjacent side. So I know that the cosine of y is equal to adjacent over hypotenuse. Okay, so how do I get rid of cosine? Well, I take the inverse of cosine. So I'm simply going to take the inverse cosine of 8/19. So y equals, and here's how that looks. We go ahead and hit the second button, cosine of 8 over 19. I put that ratio in there. And there you get 65.1 if I'm rounding to the nearest tenth. Or actually to the nearest degree, so 65 degrees. Approximately 65 degrees. Okay, find the measure of x. Now, notice in this one, they didn't give you a picture. So understand that the measure of x, if xy is 14 and xz, xy, we are referring to the same picture, but they're changing the measurements. So this is your hypotenuse right here. And if I'm referring to angle x, and xy would be the opposite. So that would be sine of x equals 5 over 14. So we're going to take the inverse sine of 5 over 14. So again, second, 5 over 14. And there you have it. To the nearest degree would be 21 degrees. Alright, so we can use the same thing. Now, here's the cool thing. What if I am given this? So I'm given the ratio, sine of A equals 6 over 7. Well, remember, sine is opposite over hypotenuse. So 6 is my opposite side. 7 is my hypotenuse. So what I need to find is adjacent. And it's a right triangle, so we're actually going to go back to use the Pythagorean theorem. If 7 is my hypotenuse, I'm going to refer to the adjacent. I'm just going to call it a. So a squared plus 6 squared equals 7 squared. That's 36 and 49 here. I'm going to subtract the 36, and I get 13, and then take the square root of that. I get a equals the square root of 13. Just double checking, 49 minus 36 is indeed 13. Now, I know that's a radical, but we're okay with that. We are okay. So I'm just going to leave it as the square root of 13. Now, it satisfies my Pythagorean theorem. It's not a Pythagorean triple, but it satisfies the theorem. And it gives me my adjacent side is the square root of 13. So the tangent is opposite over adjacent, which would be 6 over the square root of 13. Now I know that's not typically a simplified answer, but I'm going to let that go, mostly because in Alex, they accept that. I only know this because I was helping somebody with it the other day. I was not sure. I thought maybe they'd make you rationalize the denominator and make it 6 square root of 13 over 13, which you could also give me that answer, but it's okay in Alex to leave the radical in the denominator on those trigonometric ratios. And sorry, got on a sidetrack there. Sorry, last one, cosine of A is going to be adjacent over hypotenuse. So adjacent is the square root of 13, hypotenuse is 7. So that would be those two ratios. All right, so using what we know about the trigonometric functions, we are going to find ratios and then maybe even finding angles. So hopefully you understand when to use that inverse sine and inverse cosine. If not, guys, just come talk to me. But hopefully you're good. All right, good luck.